Hello? Is this on? Hello? Is it on?
I think it's on.
Alright. Okay, we are going to start. I hope you guys all had a good spring break. Today we're going to be talking about networking and Cocoapods. Some logistics. Last day to drop is tonight. Project reminders. We have Project 5 due next Sunday. And then there's also an extra credit for closures, which is due this Thursday. It gives you 4 extra credit points, so I suggest that you do it. It's also very useful just to understand networking in general, so I highly suggest that you do it. And then Mindy is going to be talking about the hack challenge.
Okay. That's fine, I don't need it. Okay, so as a reminder, the hack challenge is like the end of the semester final project for this class, and it's going to give you a chance to like collaborate with students in design and backend and iOS to create like a really cool product. And so that's going to be starting on Monday. So what we want you to do is like start coming up with ideas. So just to give you a sense of like what we want, it's basically you have 3 weeks to build something, and you should have 4 team members, max 2 iOS, max 2 backend. You must have at least 3 members, and then design is like on top of that. And then this is our timeline. So what we ask of you is to submit like an initial idea. I'm going to send out the Google form after class, but basically you just submit like a couple sentences or like up to a page of what you like, an idea that you have. It doesn't have to be something that you like are like 100% set on. It's just basically so that you can brainstorm and have something in mind for the hack challenge. And then we're going to have a kickoff and team formation on next Monday during the backend class time. And that's where all the iOS backend and then the design students who want to participate are going to come. You can like mingle, form teams, and then we'll have team matching. Like we'll release the official like set of teams, assign you to an iOS and a backend mentor, and then you could like start working. We're going to have like midpoint checks, so you should really use your mentors as a resource. Your mentors are going to meet with you and your team between like April 24th to 26th, and you get to coordinate this with your mentors. They basically get to see, you know, how far along you are and just like hold you accountable so that you're on track to finish on time for the end of the hack challenge. And then we have our midpoint submission, which is just like how much you've done so far on CMS, and then we'll have a final submission, which is like a GitHub link that you're going to send to us and via Google form of like all of your like project, and then we're going to have a closing event, and we're going to have winners. We're going to have prizes for those winners. We're going to have food. It's going to be a great time. Anyone have any questions about the timeline? All right. So for the iOS portion, this is what we ask of you. There's 4 minimum requirements. The first is you must use auto layout, basically what we've been doing in class all semester, using either NS layout constraint or SnapKit, which is something that we might have time to go over. And then we ask that you have at least one UI collection view or table view to display some sort of data, some form of navigation, so either a UI navigation controller, modal presentation, or a UI tab bar controller, which is something that we did not go over in class, but is super useful. It's like the 4 buttons on the bottom of the screen that you see in a lot of apps to navigate between screens. And then integration with an API. And basically what this is saying is, we'll go over this later in class, but like this is how you're going to integrate your app with the internet or with like a backend. So an example of an API or like a backend that you could use is one that the backend class writes, or students in the backend class will write, or you can use an external API like Yelp, Google Maps, like Spotify, Apple Music, something like that. Any questions?
Cool. If you have any questions, you can come up and ask us at the end of class. So now we are going to go over some cool submissions. Let me pull up my... Okay, so the first person is he here or is she here? Kai Stroll? Unfortunate. He also added like an app logo, so that's cool.
Ooh.
So if you click on it, you'll see we have like our table view of songs. You can click on it, and then I actually wasn't sure how this play thing worked because it seemed kind of buggy. Like, what do you do? Like, do I click tap? It's like it'll play music like sometimes, but I wasn't sure how it really worked. I was hoping it would be here, but it does work sometimes. Let me get my sound. It's playing music, and you can stop it. And then if I click play, it doesn't do it again. But it works sometimes, so it's still very cool. I wish he was here. Leo Liang is here. Unfortunate. Wait. Oh, there we go. There we go. So yeah, now we have we have our table view of songs. We got some Chinese songs, some Korean songs. If you click on them, you'll see there's like an image. You can edit the image URL by providing like a URL. You can also edit the play link URL. So if we click on this, it'll actually bring you to the YouTube link for that video, and you can listen to the song. That's pretty nice. And then you can edit, and then when you edit, you can either delete or drag to rearrange them. So also very very cool. Add song allows you to create a new song basically. Yeah. Cool. Next is Hai Ying Wang. Oh, nice. Hai Ying Wang. Hai Ying Wang right here. So we have our radio songs. We have a shuffle play button. Yeah, I actually like the songs in here. So it plays songs, and you can rearrange them, and you can pause and play again. So very cool. Good job. And then last one is Jeremy. Oh, nice. Jeremy's here too.
Wow. Amazing.
Thank you for coming to class. Jeremy. So now instead of our just like one table view of songs, we have playlists, and playlists themselves have songs. So if you click on the playlist, you'll see I have like these songs, and then I can actually click on this to play the song. So that's very cool. You can click on it, you can add artists and save them. But yeah, this is pretty cool. You use like MP3 files, right? Yeah, so he added like MP3 files to his project, and then when you click play, it just plays that file. So very cool. Nice job. Also, thank you for coming to class. Cool. So now let's do some review from last lecture. The first question is, what is one reason you would use a UI collection view over a UI table view? If you know it, you can just raise your hand. Jeremy, you want to take a guess?
You would use a display using collection view. You can scroll in both directions.
Yeah, exactly. So the answer is C. So unlike a table view where you can only scroll vertically, for a collection view you can specify whether or not you want to scroll vertically or horizontally. And we also instantiate UI collection views with this thing called a UI collection view flow layout, which essentially allows you to lay out and display items in a grid, sort of like the Photos app. Any questions? Cool. How do you set the spacing of a UI collection view? Any guesses? Who was the other person that came to class? Oh, you're right. Can you answer?
Like spacing between each cell.
Yeah.
Is it B?
It is not B. But nice guess. Anyone else want to guess? Or do you want to take another guess?
50-50 chance, right?
Huh?
C?
Yeah, C. So when you set the spacing, you actually can't do it directly on the collection view. You have to specify it through the layout. So you can't do collection view dot minimum line spacing, but you can do layout dot minimum line spacing. Any questions? And then this is, so we noticed while grading some projects that some of them were very, very similar to lecture code projects, which I mean, it's not like horrible, but like if you want to learn, the best way to do it is to create a new project, and if you like forget stuff, then you look back to the lecture code. So the answer to this is B. Yeah, I'm not like saying this in specific to anyone. It's just like this happens like every semester, so we just have this question up every time. All right, cool. So networking. Today we're going to be talking about networking. What is networking? It might sound complicated, but all it means is connecting your app to the internet. And one thing you might be wondering is, why do we want to connect our app to the internet, right? So let's say someone hired you to build Facebook, and they asked you to build this feed, right? The way you might do it right now is you probably have a clause for like each post, and then you probably like hard code. Oh, post 1 has this title, this number of likes, and this number of comments, and then post 2 has this number of likes, this number of comments. But there are two main problems with this. If we're hard coding every post, the first problem is, let's say my friend like wakes up at 5 a.m. and makes a post. How do I know to like wake up and then add that post, right? The second problem is like this obviously isn't scalable. Like when the number of posts reaches like billions or whatever, having to hard code every single one won't work. So the reason we need networking is specifically for this issue. So how do we actually connect our app to the internet? This is done through something called HTTP requests. All this means is HTTP requests is the way that your app communicates with the internet. So in this case, or clients communicates with servers. In this case, the client is your app, and the server is just something that exists on the internet. Yeah, you guys actually make HTTP requests every single day. So for example, if you go to google.com, what you're doing is you're making a GET request to the Google servers, and then the Google servers return some data to you. So a nice way to visualize this is if you go into, I have this app called Postman, and basically what it allows you to do is like make requests, and then you'll like see the response. So you see that if I go to google.com and make a GET request, the response I get from the Google server is just a bunch of HTML, which is what gets displayed, right? So basically, whenever the client makes a request to some server, the server returns some data, and that data can take many different forms. In this case, the data returned is in HTML format, but you'll see later on it can take on other formats as well. Any questions about that? Cool. So we have three main types of HTTP requests: GET, POST, and delete. There are many more, but for the purposes of this course, you'll only need to know these three. So what's the difference? GET is usually made to like is usually done to retrieve some sort of data. So for example, if you had an app like Facebook, you would probably make a GET request to fetch all the posts in your feed, right? A POST request is used to either create or update some model inside the server. So again, using the same analogy, if I wanted to make a new post, I'd probably make a POST request to my server, sending them my title, my body, and like my user ID, for example. And then the server would create a new post model inside their database. And then a delete request is usually done to tell the server to delete some model. So if I wanted to delete my post from last week, I would send a delete request to the server, and then the server would delete that post from the database. Does that make sense? Cool. Now we're going to be talking about JSON. What JSON stands for is JavaScript Object Notation, and basically what it is it's basically just a dictionary. So like dictionary, as you know, has keys and values. In JSON, the keys are of type string, and the values can either be of type strings, objects, numbers, booleans, arrays, or null. So it's essentially just a dictionary object. As an example, this is one. So we have our JSON. It has 3 keys: name, age, and favorite foods. The value corresponding to name is Mindy of type string. The value corresponding to age is 21 of type int. And the value corresponding to favorite foods is an array of strings. So it's very similar to just like a normal dictionary. Any questions? So why do we care about JSON? If you remember what I said just a couple minutes ago, the data that's sent back from the server can take on many different formats. When we make a GET request to google.com, they return data in the form of HTML. But usually when you hit a server, the data they send back will be sent back in JSON format. So the reason we care about JSON is because we'll be working with them inside our app. Before we can delve further into connecting our app to the internet, we have to talk a bit about external libraries. So what are external libraries and why do we care about them? So whenever you develop an app, you're probably going to run into issues or things that you'll need to do that other developers in the past have also needed to do. The reason that external libraries are useful is because they allow you to save time by using code that other developers have provided you with. Yeah. So how do we manage these external libraries? The way we do that is through this thing called Cocoapods. Cocoapods is just an external library manager for Swift and Objective-C. So let's say I wanted to add an external library to my app. What I could do is use Cocoapods to install it into my project and then use that code in my project. If you've done Python or Node before, it's similar to like pip or npm. So it's just like a way for you to install and add new external libraries to your application. Any questions about that? So these are 2 examples of libraries that we use. On the left is Eatery. So we use this library called Hero, which is an animation library. Basically what it does is it allows us to create this sort of animation. So if I click, so that sort of animation right there, we didn't code that ourselves. We just use this library called Hero, and that allows us to have this. And then the second library we use is Google Maps for Ithaca Transit, and this library just essentially allows you to incorporate a map into your app, into your application. So how do we use Cocoapods? Well, first thing you need to do is install it, which you guys should have all done. Does anyone not have it installed? Yeah, cool. And then once you have Cocoapods installed, what you want to do is go inside the directory containing your project and then run pod init. I'll go over this again later, but basically what pod init does is it creates a pod file. Pod file, you can think of it as just like a text file inside your directory. It looks something like this. A pod file is just like a text file, and then inside it, you basically just have to list all the external libraries that you want to use. Or in this case, they call it pods. So this is a screenshot from Clicker or Polo's pod file. And you'll see we have like a ton of different libraries that we use. AlmoFire, Google Sign-In, SnapKit, etc. After you create the pod file and you list all the libraries that you want to use, you want to run pod install. Pod install is a command that installs all these libraries and then creates a new file called a .exe workspace file. And essentially now anytime that you want to open and edit your project, instead of opening the Xcode proj, you want to open the XC workspace. The reason for this is because only inside the XC workspace will you have access to these libraries. So if you open Xcode proj, you won't have access to them. Any questions about that? Okay, so now we're going to try setting that up for our starter code. So first thing you want to do is first download the starter code if you haven't already, and then go to Finder and like just navigate to your folder that contains the Xcode proj. So like right here, this folder contains some Xcode so I want to go back and go there. You also want to open a terminal. So to open a terminal, you can just go to search and type terminal, and then it should open up. I'll give everyone a couple of seconds. Cool. So next thing you want to do is you want to hold this, like you want to click on your folder that contains your Xcode and just drag it to your terminal. What that will do is it'll open up a new tab, and where like you'll be inside that directory. So like if you do ls is the command that tells you that lists all the files that are in the current directory. So if you do ls, you'll see that I have my Xcode project in there. Does anyone need help with this? Cool. So now first up, we want to run pod init. Again, what this is going to do is it's going to create a pod file. So if we run pod init and then do ls again, you'll see that now we have this extra file called pod file. And now what we want to do is edit it. So you want to do open pod file and then click enter. What that'll do is it'll open up in Notepad, I think that's what it's called. And basically all you want to do is go right below where it says pod for L6 starter, and then type in pod. The pod we're going to be using is called Almofire. So you want to do pod Almofire and then single quotes, and then save. We're actually going to be using SnapKit later, so let's just add that as well. So pod SnapKit, and then save that file.
Can you go back to the terminal?
To terminal. So the command is pod init, and what that does is it creates a pod file. And then what you want to do is open that pod file and then add these 2 lines. Can I move on? Cool. Now that you saved it, you can close it. And then you want to go back to your terminal, and then you want to run pod install. What this is going to do is it's going to install all those pods that you listed in your pod file, and then create a new XC workspace. So you'll see here, after when we run pod install, it says to please close any current Xcode sessions, and then use the XC workspace project from now on. So now we never want to use Xcode project. We want to open the L6 starter.xc workspace. So you just do open L6 starter.xc workspace. It should open it in Xcode. That's my thing messed up. Uh-oh. I might have messed around with it before. Hold up.
It's because you have it open, don't you?
Oh, is it?
Isn't this open?
Wait, you're right. Oh, you're right. Nice.
Yeah. Do you have a question?
Yeah. What was the syntax again for like in the pod file?
I can show you. So you just wanna do pod and then space and the library name. So pod Almofire in single quotes and pod SnapKit in single quotes. And then after you save it, you want to run pod install, and then you should get a XC workspace file. Anyone have any questions about any of those steps? Cool. So I'm going to move on. So now we have our starter code. Let's try running that and see what we have. So actually, let me show you what the demo project is going to look like. So the project or the demo we're going to be building today is we're just going to have a app that displays a table view, and this table view is going to be a list of courses. So like Intro to iOS development, Intro to computing, etc. So yeah, that's the app we're going to be building. In the starter code, all we provide with you is like empty table view. So now we're going to actually start doing a bit of work on this. So if you go into viewcontroller.swift and scroll all the way to the bottom, you'll see that inside the extension that extends our viewcontroller to UI table view delegate, there's nothing there. Does anyone want to guess why? Or like what kind of methods would you normally implement when you conform to UI table view delegate? They're all optional, but sometimes you want to implement some. Jeremy, you have a guess?
I was just gonna ask you to repeat the question.
Oh yeah. So if you see right here on the bottom, the extension that extends our view controller to UI table view delegate is empty right now. The question is, why is there nothing here? So like think about what methods you normally implement when you extend UI table view delegate, and then think about if it's necessary for our app. So I guess the first question is like, what sort of methods do you normally implement for when you conform to UI table view
But
delegate?
you have to take that stuff from the API, right? Because it's
No.
You usually list. It's like you return the number of cells, right?
Number of cells is inside UI table view data source. So you have number of rows, cell for row, and height for row here. So just to remind you guys, a method that is like a part of UI table view delegate is like did select row at or did deselect row at. But in this case, we're not doing any interaction, so we don't actually need to implement them. Yeah. Cool. So what we want to do is the table view cell and course file is all set up. What you want to do is go inside this network manager file. If you go into network manager file, you'll see this string constant called endpoint. If you copy and paste this into your browser, you'll see by making a get request to this endpoint, we get back this JSON data, and you'll see it has like a couple of classes. What we want to do is make a request to this endpoint, get the JSON, decode that JSON, and then use that to display our table view. So first thing we're going to want to do today is just first make the request to this endpoint and then print the JSON that we get. So the way we're going to do that is we're going to first make a class called network manager. And this class is going to handle all of our HTTP requests. And then we're going to make a static function called getClasses. And it's not going to return anything for now. Do you guys know what static functions are? Or who knows what static means? Okay, I guess I'll explain it. So normally if I have a function, just like a regular function called like random function, for me to actually call this function, what I would have to do is like make a network manager, right? And then do network manager dot random function, right? But what static function means is that essentially it makes the function a property of the class rather than a property of an instance. So in this case, random function is a property of an instance because I first have to make an instance of network manager and then I can call it. If I make getClasses static, what I can do is instead just do network manager dot getClasses. Right? If you notice, I can't do network manager dot random function, or you shouldn't be able to. That won't work. But yeah, essentially what static allows you to do is it allows you to call some function or call some field without actually having to make an instance of that class. Does that make sense? I can repeat that again. Cool? Yeah, so we're going to be making this a static function. And inside here, we're going to make a HTTP request to this endpoint. So to do that, we're going to be using the animal fire library. So in order to use that library, we have to import it first. So at the very top of the file, you want to do import animal fire and click enter. And then inside this getClassed function, the way we make a HTTP request using animal fire is by doing animal fire dot request, and then you're gonna want this first one. So this request method takes in a lot of different arguments, but most of them are actually optional. So we can get rid of all of them except for URL and method. So for URL, all we have to do is pass in the string representing our URL. So that's endpoint. And then for the method, does anyone want to guess what method we're going to be using? So it's either get, post, or delete. Get, exactly. So in this case, we're not making any requests to like create a new model or delete a model. We're just trying to retrieve some data. So we're going to be using the get method. After we call request, we want to do .validate. And what this does essentially, if you ever, I don't know if you guys have ever seen this, if you go on the internet and then you randomly click on some page, you might get like a 404 error. And what that means is like the server essentially errored in giving you any data. What calling .validate does is it's going to make sure that the status code that we get back from our server is 200, which means, okay, like we actually got a good response. Any questions about .validate? So it just ensures that we actually get a good response and not like a 404. And then next thing we want to do is do .response data. And if you see response data, it takes in one argument, completion handler. But the type of completion handler isn't like a boolean or int. It's actually a function. So this is this is essentially just a closure, which if you guys do the extra credit, you'll understand it. But I can go over it very quickly. Closures are essentially just like anonymous functions, which means they're functions, but they don't have names. So normally whenever you create a function, you do func, you give it a name, and then you pass in the arguments, and then you have some body, right? What closures are functions without names. So completion handler is a function that takes in one argument of type data response data, and it returns void, so it has no return. So what I'm doing is I'm passing in a function to this response data method. The reason it's asking for a function is because once we get the response from the server, it's going to convert it into a data object and then call this function by passing data as its argument. So if you click enter, it'll actually do the formatting for you. So here is the argument. So we need to give our argument a name. So we can call it response. And then inside here, we want to provide the actual body of the function. Does that make sense? So by passing in the completion handler, what that does is once we get a response from the server, animal fire is going to convert that response into a data object and then call our function and pass in that data as response. Does that make sense? Cool. So now that we have our response, we want to check if it's valid, right? So what you want to do is do switch response.result. So if you switch on response.result, response.result is actually an enum. It has two cases, success and failure. So if it failed, we just want to print the error description. But if it succeeds, we're gonna want to do something else. So the reason we want to do this is we want to first see if our response actually gave us any data. If it didn't, we just want to print the error. If it did, we can now do something else. So if it succeeds, let's say we just want to print the JSON. The way we can do that is by doing we're gonna be using an if let. So let do if let JSON equals JSON serialization, and then dot JSON object with data, and then click enter. If you look at this, you'll see that this function actually throws an error. So to handle that, we're gonna add a try statement in the beginning. You don't have to worry about that too much. It's just essentially a way for us to not have our app crash if it throws an error. And then for the data, we just want to pass in data. And then for options, you can just pass in an empty array. And then if we have the JSON, let's just print the JSON. So what we're doing is, if we actually get a response, let's take that data object and then convert it to JSON and then print that JSON. Cool, so now let's actually call this method. So what you want to do is go back to ViewController, and inside get courses, we can make our call to the network manager function that we just wrote. So do network manager.get classes, and then we can run our app. So if we run our app, you'll see that we now have something printed to the console, and it's our JSON that we saw right here. Cool, so that worked. That's all we're going to be doing for networking as of today. Does anyone have any questions about networking so far? Cool, okay, so next thing we're going to be doing is going over another library that we actually use in app dev. It's called SnapKit. So what is SnapKit? SnapKit is a better way to do auto layout. So you guys probably have noticed, like, by using NS layout constraints is nice because it works. But like oftentimes you might forget to do like translates all resizing masking constraints to be false, and it'll just like not work at all. The other good thing of SnapKit is that it's very like concise and short. So the way we install it is just by adding it to your pod file and then do pod install, which we already did. So let's look at an example. So let's say we had a view and we wanted to add these constraints, right? We would do dot translate all resizing mask equals false, and then pass in all these constraints. Let's look at the first constraint. So first constraint is we want the leading to be 8 pixels offset from the view's leading. What we can do if we were to use SnapKit is we don't need to do the dot translates all resizing mask constraints. Instead, all we need to do is do make dot leading dot equal to superview dot offset 8. So in this case, the superview is just the root view controller's view, and then we want to make it equal to that, offset by 8 pixels. And then similar for trailing, if we want the trailing to be equal to our view's trailing, offset by -8, all we need to do is make that trailing dot equal to superview dot offset -8. And then if we wanted our top and bottom to be equal to the top and bottom anchors respectively, we could do make dot top dot equal to superview and make dot bottom dot equal to superview. Or you can also do it in one line and just do make dot top dot bottom dot equal to superview. So with SnapKit, the constraints are very concise and you don't have that as much code. So we can try doing this inside our project. So if you look inside the view controller class, inside setup constraints, you'll see right now we're doing it the old way. Let's first import SnapKit. And then first thing we can do is delete this translates all auto resizing masking into constraints. And then inside here we can comment out this code. So inside here what we want to do is do table view dot smp dot make constraints. Click enter. You'll see that make constraints also takes in a function, a closure. You just want to click enter, type in make, and then in here we can actually create the constraints. So if you want to make the table view's top anchor equal to the the view safe area layout guide top anchor, what we can do is do make the top anchor, make the top dot equal to, and then view dot safe area layout guide dot top anchor. Oh, my bad. Dot SMP dot top. I haven't done this in a while. And then similar for leading, we can do make dot leading dot equal to, and then view dot snap the, actually no, we can just do equal to super view. So if anchors are the same, you can just do equal to super view, and they'll match leading with the leading. And then similar for trailing. And then for bottom, we can do make dot bottom dot equal to view dot safe area layout guide dot SMP dot bottom. So this is how we would translate these constraints into SnapKit. If instead we were to constrain our top and bottom anchors to just like view dot top anchor and view dot bottom anchor, what we could do is instead just do make dot top dot leading dot bottom dot trailing dot equal to super view. Now what used to be like 5 or 6 lines is now just 1 line. Another way to do this is just do make dot edges dot equal to super view, and this will pin all 4 anchors to the super views anchors. Does that make sense? Any questions about SnapKit? Cool. You guys can use it inside your projects and the hack challenge if you want, just because like I think it's a lot nicer and it'll probably save you some time. Cool. If there are no questions, some action items. So just a reminder, the proposal is due on the 11th, which is on Thursday, I believe, through the Google form. The kickoff is going to be next Monday at 8:30 p.m. So right after our lecture, you won't have to go anywhere. The project 5 is due on Sunday, and the extra credit is due on Thursday as well. If there are no other questions, that's it. Thank you for coming.